6.2, factoring by grouping. I have a few examples up here. It's going to relate to that last example we did in section 6.1. But to be fair, once we're done with chapter 6, right, we're going to be so good and efficient at factoring that factoring by grouping probably won't even affect how we approach a problem. All right, this is one way, and it's a good explanation of what's going on. So it's a good place to start. But when we look at 6.3 and 6.4 and 6.5, right, we're going to come up with better ways to factor than factoring by grouping. Right? But it's a good transition here because we're still going to be looking for GCFs. Factoring by grouping is good when you have 4 terms, and specifically 4 terms, because we're going to look at them in groups. We're going to say, I'm going to look at these first 2 terms, and I'm going to look at these other 2 terms, and I'm going to try to find a GCF amongst those groups. So it might help to say, okay, I'm going to look at these first 2 terms by themselves and find a GCF, and I'm going to look at these other 2 terms by themselves and try to find a GCF. And we'll see what the goal is in a second. So I'm going to look at these first 2 terms, and what's the GCF between these 2? Well, they don't have much in common, but they do at least share a y, and the lowest power of y here is just y. So we can remove a y from the first grouping. And if we want to remove it and see what's left over, we would need one more y. Right? Y times y will be y squared. And we'd be left with just a 2 here. Right? Y times 2 is 2y. So we did factor out a GCF of this first grouping. But the goal here, and to do this correctly, is once we take out a GCF, we're going to be left with an expression y plus 2, some binomial, some polynomial that's left over. The goal here is if this is to work out right, we want to be able to factor this other binomial or this other grouping so that we also have a y plus 2 left over. So we want to try to figure out, how am I going to get this y plus 2? Or is it even possible to get this y plus 2? So when we're looking at this second grouping, right, they do have something in common, at least numerically they have a 5 in common. But what might help us even more than the fact that they just have a 5 in common is the fact that they have a negative 5 in common. And we'll see why that's helpful or better than just 5. Right, so they have a negative 5 in common. I'm going to remove a negative 5 or divide them both by negative 5. Right, so we removed a negative 5 from that second set. Right, what would be left over? I would have negative 5 times y. That would give me negative 5y. And negative 5 times a positive 2, negative 5 times positive 2 would be negative 10. So notice both of these pieces that are left over, these binomial pieces, are identical. And that's our goal. If these are not identical, we actually can't go any further, and it was useless for us to try to factor by grouping. So we need identical factors. All right, if you can't make this happen, all right, then go back to the drawing board and try again. Maybe try to use a negative. All right, and sometimes maybe you can't do it at all, in which problem we would say that polynomial is prime and you can't be factored. But I would say for the most part, any problem that I give you, all right, would definitely be able to be factored by grouping. All right, and now this looks a lot like the last problem we did in 6.1, where this whole expression here, right, has a y plus 2 in it, and this whole expression here has a y plus 2 in it. So we can say these now have a GCF of y plus 2. Right? They have common factors of y plus 2. Right? So what would be left over if I removed a y plus 2 from this expression? Well, just a y. What would be left over if I remove a y plus 2 from this whole expression? Well, a negative 5. Right, and here we go. We've successfully factored this twice. Right? We split it into groups and found GCF. Right, and those individual groups gave us common factors, and we did a GCF again. So it's 2 iterations of this GCF process. And we can do these other 2 examples the same way. Let's look at this first grouping, right? A AB and negative 4A. These two just have a variable in common of A, so we can remove an A. If we took an A out of here, we just have B. If I took an A out of this term, I just have a 4. So that looks good. Right here, right, remember our goal is I want to find this factor over here, so I better come up with a B minus 4 if I'm going to do this correctly. So in between these two terms, they just have numbers in common, and in fact, they both can be divided by 9. So let's see if that works, a positive 9. So let's remove a positive 9 from here. If I divide this by 9, I've just got B, and I divide this by 9, I've got negative 4. Right, perfect, this is exactly what we want. So we have these common pieces, and this expression has a B minus 4, this expression has a B minus 4. So we can GCF this one more time and say their greatest common factor is B minus 4. What's left over? A single A and a positive 9. And this last example illustrates the same. Looking at these first two terms, 4x squared and 6x. They have a common factor. They're both divisible by 2, and they both share an x. 2x times 2x, we get 4x squared, plus 2x times 3, 2x times 3 would be 6x. So we removed a 2x from the first pairing. Let's look at the second pairing and see what we would need to get. Hopefully we can get a 2x plus 3 out of it. Right, these two guys have in common, they're both divisible by 4. But if I just divide them by 4, I'm going to have a whole bunch of negatives floating around. I don't want that. I want all these to be positive. So if they both have a negative, especially if this first piece right here is negative, I'm going to want to factor out the negative. I would say almost all the time. If this term is negative, let's make sure we factor out a negative 4 and see what's left over. Right, if I divide this term by negative 4, negative 4 times negative, nope, not negative, negative 4 times 2x, negative 4 times 2x would be negative 8x. And negative 4 times positive 3, negative 4 times positive 3 would be negative 12. And there we have it, perfect. 2x plus 3 common factors, this expression share that 2x plus 3. We're going to remove it. So if I remove a 2x plus 3 from this big piece, I have a 2x left. If I remove a 2x plus 3 from this big piece, I have a negative 4 left. And we have that factored. All right, so yeah, it's a good skill to have and be able to use. It practices finding GCFs. It's just really not too common to kind of just try to group two terms together and find a GCF. In lots of instances, that is not useful whatsoever. Just in these very specific cases where I know that this grouping is going to give me a nice factor and this grouping is going to give me a nice factor that are identical, then we could keep going with this. But we'll see in 6.3 and 6.4 and 6.5 that there are better ways to do this.